Hey there, guys. Today we're starting Unit 5. 5.1 is on Polygon Sum Conjecture. So a reminder, a polygon is a closed figure in a plane formed by connecting line segments endpoint to endpoint. That's a definition from 1.4. So we have a variety of polygons here, and we're going to talk about them on this page. All right, so our first one we see is a triangle and it has 3 sides. We're going to get to the polygon sum conjecture, but we're going to help ourselves get there using these 4 polygons. Okay, what's the least, so it has 3 sides. What's the least number of triangles that can be broken down into? Well, 1, the triangle it is, so 1 triangle. Okay, and a triangle we know has a sum of 180, so the interior angles have a sum of 180. Okay, and how many interior angles are there? Well, there are 3 of them. So the 3 of them add up to the 180 that we've talked about. Okay, the next one is a quadrilateral. That's any 4-sided figure. That could be kites, trapezoids, parallelograms, rhombus, squares, rectangles, all those. Okay, and it can be broken down into 2 triangles. Okay, so each of those 2 triangles is worth 180 degrees. So the interior angles have a sum. There's 2 triangles. They're both worth 180, so 360 degrees. So any 4-sided figure is going to have a sum of 360 degrees. And that's the interior, the inside angles. Okay, the next one is a pentagon. It has 5 sides. Okay, and I can break this down into 1, 2, 3 triangles. Each of the triangles is worth 180 degrees. So my sum of my interior angles is going to be 3 times 180, and that is 540 degrees. And then we see our next one. It is a hexagon, and I'm going to break this down into 1, 2, 3, and 4 triangles. So it has 6 sides, and it's 4 triangles. So the sum of the interior angles is going to be 4 times 180, which we are left with a 720. Okay, so what I was just doing, for any polygon, you can break it down into the least number of triangles. You can multiply it by 180. Notice, now look at how many sides it has versus how many triangles it is. Okay, look here. What pattern do you see from how many sides to how many triangles? Yep, there's always 2 less triangles than there are sides. So the number of sides minus 2 is always the number of triangles. And then we multiply the triangles by 180. Okay, so if a polygon has n sides, so n can represent any number. It can stand for 17 to 143 to 1,037 sides, okay? So if we think back to this page, and n is our number of sides, how many triangles does it have? So it has n sides. So it's n minus 2 triangles. Okay, so that's just following here. 3 minus 2 gave us 1. 4 minus 2 gave us 2, etc., etc. So we have n sides, n minus 2 triangles. Okay, then to find the sum of our interior angles, we took our number of triangles times 180. So we're going to take our number of triangles times 180, and usually you see the 180 out in front. This formula is going to tell you the sum of the interior angles. For any polygon, you plug in how many sides it has, minus 2, and times that by 180. That's going to give you the number of, or the sum of the interior angles. Okay, so remember equal angular means all of the angles are congruent or equal to each other. So let's just make a little chart to help you out here that are the first few. So we have triangle, we have a quadrilateral, we have a pentagon, we have a hexagon, we have a heptagon, we have an octagon. Okay, and you can keep going. We have nonagons, decagons, unigons, dodecagons. We've talked about those before. So the number of sides, 3, 4, 5, 6, 7, and 8. Now, I don't have a column here for the number of triangles, but remember the number of triangles is 2 less than the number of sides. So the sum of the interior angles, here we have 1 times 180. So 180 we said. We have 2 times 180, 360 degrees, and that goes for any quadrilateral, any four-sided figure. 3 times 180, we have 540. We had 4 times 180, we are at 720. Okay, and then let's see here, 5 times 180, we end up with 900. Okay, and then 6 times 180, we end up with 1080. Okay, so this is a little cheat sheet to help you. Here's your sum. Remember, if you're asking yourself, how did Mrs. Matheson get these numbers? These ones came from the number of sides minus 2. That gave us our number of triangles. If you want to find the each individual interior angle, so in a triangle, and now this only works for equal angular, remember, equal angular. So all the angles are equal. Only works for equal angular to do this last column. Let me write equal angular only. Okay, so in a triangle I have 3 angles, so I can take 180 and divide it by 3. So each of the angles in the equal angular triangle is going to be 60 degrees. Okay, we can do it again. We have a total of 360. There are 4 interior angles in a quadrilateral, so each of them is going to be 90 degrees. Okay, you can do this for a pentagon. If it's equal angular, we divide by 5. Each of them is 108 degrees. Okay, if we have a hexagon, it has 6 angles. So 720, we divide by 6. Each of them is 120 degrees. In a heptagon, we have 7 angles. So we're going to take our 900 and divide by 7. We get 128.57 degrees. So we end up with a little decimal there. It goes on a little longer. I just rounded it to 2. And in an octagon, we have 8 interior angles. So 1080 divided by 8. Each of them is 135. Now that only works when it's equiangular and each of the angles is congruent to the other ones. Keep that in mind. All right, here's your practice for this, and we will see you guys later.